There are 3 ways the complement system can go about its business, each one triggered by a different kind of stimulus, but they all end the same way. The alternative pathway and the lectin pathway can be fired up even when your immune system has never met the microbe and doesn't have ready-made antibodies, while the classical pathway is sparked into action when antibodies bind to their antigen targets. Let's take a closer look at the classical pathway. When an antibody binds to an antigen, it creates an enzyme that activates a complement protein called C1. The C stands for complement, of course. There are 9 complement proteins. Activated C1 causes C2 and C4 to come together and then split to make 2 new proteins. One is a signal for immune cells like macrophages to come and join the fight. The other protein is an enzyme called C3 convertase, which, you've guessed it, converts C3 into 3A and 3B. 3A leaves to fetch more immune cells. 3B gets stuck into the microbe's membrane or its shell. 3B makes the microbe irresistible to macrophages and also becomes an enzyme, C5 convertase, which, wait for it, converts C5 into 5A and 5B. While 5A recruits even more immune cells to the area, 5B brings together complement proteins 6 to 9, forming the membrane attack complex, or the MAC. MAC is a knife punching holes right through the microbe's shell. Cell contents leak out and water pours in until the doomed microbe swells up and poof. That's the good news. But every ologist needs to know what happens when complement goes bad. Keep watching to find out.